Good afternoon, everybody. It's 2 p.m. in Warsaw, and we are having a pleasure being together at this UNIgreen Joint Research Center number 4, Biodiversity, Forestry, and Agroecology seminar. Today's seminar will be presented by my colleague, Marta Trzcianowska. She is a graduate from University of Laval in Quebec, Canada, and she will tell us more about wood yards and how to design them. But before we start, I would like to introduce you with some of the schedule of our meeting. So first of all, this meeting will be recorded for all of you that would like to ask a question at the end or speak, and that to know that your voice will be recorded. We will have first about half-hour presentation by our presenter today, followed by Q&A at the end. In the top panel of your Teams window, you have Q&A button that will drive you to the Q&A place that you can ask the question we will read out loud at the end. And after the discussion, I'll have one announcement, and we'll finalize the seminar roughly in 1 hour starting from this moment. I hope that everything is understandable, and now, without further ado, we'll proceed for the presentation. So I will give floor to Marta.
Thank you. Hello, everyone. Thanks for being here. Thank you, Wojciech, for the introduction. So today I'm pleased to talk a little bit about wood yards, important aspect in wood logistics, wood yards in Eastern Canada, principally based on my PhD project finished in 2020, but also based on further experience at government, where I had great opportunity to work with forest industry to modernize the wood supply chain in Quebec. So just before the wood yards, I'll provide you some insight into forestry context in Quebec. Quebec is the most important forest province in Canada. I marked in a red color the contours of this province. So now some important statistics, recent statistic, 2024. Forest in Canada covers the area of 19 million hectares, which is 2.2 of the world's forest. And Canada by itself, it's almost 14% of the world's forest. 92% of those forests are public ones, mostly provincial, but also federal and municipal. And 90% of public forests are certified. In Quebec, we have about 30% of production forests, which means managed forests, accessible for forestry machines, and so the terrain without slopes, without any types of protection zones. Among these forests, about half of them is coniferous one, with black spruce and balsam fir. Then mixed forest, 26% with balsam fir and paper birch, and hardwood forest, 17% with sugar maple and yellow birch. In Quebec, we harvest annually about 28 million of cubic meters, and a half of this volume is processed by sawmills, 28% by paper mills, and 22% by other wood processing mills, including production of pallets, for example. The forest sector in Quebec gives direct 1,000 jobs. And now how does the wood supply chain in Quebec work? So I start with timber sales. So timber sales is mostly carried out by a so-called guarantee of wood supply from public forest. It's a right for 5 years to the processing mills having a license to process the wood, to obtain up to 78% of required volume. And the rest the sawmills or paper mills should buy at auctions or from the private forest. So with this guarantee of food supply, the sawmills or paper mills should harvest this wood by themselves, and then build a forest road to transport the wood, and then to transport the wood to the sawmills. But before harvesting, the industrials should agree between them about harvesting schedule and harvesting cost, because the harvesting sector can be assigned to more than one sawmill. So it's mostly the case of mixed and hardwood zones, where we have a lot of potential assortment, and each assortment can have a different customer. So this so-called harvesting integration could also limit the level of harvesting, because each sawmill, each company will focus on the sectors with where the most of the volume can be processed by them, and they'll avoid the adjacent sectors with the great number of species they cannot use. So these unwanted sectors are blocked and no one can harvest there. The forest is fragmented and the industrial doesn't obtain the volume they need. So as a result, there's difference between accessible volume to be harvested and the volume actually harvested. And as a result, the distance between the harvesting sector and the sawmill increase. So we have much more emissions as well for the transportation. And if you talk about the transportation, it's mostly carried out by road transport, by the trucks, with load capacity from 35 tons. It's for semi-trailers, and 40 tons, it's called B-trains, and up to 110. It's for so-called oversized truck. You can see on the second picture, it's a really big truck. So those trucks cannot drive on public roads. It's only it can only drive on private roads, and where when sawmill has a direct access to this kind of road, the sawmill can actually significantly optimize the transport, the number of trips. Average distance. It depends on assortment, because low quality wood is not transported for the long distances. So it starts from 110 kilometers average distance for the pulpwood, and for hardwood is about 30 or 40 kilometers more. The most important factor, in fact, in Quebec, influencing the transportation and harvesting operation is the seasonality of food supply, because in Quebec, we still have a real winter with a lot of snow. The logging and the transport operation are mostly carried out in this period. And we have a lot of food stock. Why? Because winter period is followed by the thaw period, where when we cannot enter the wood, the forest, and there's a lot of load limitation for heavy-duty trucks on public roads. So we have no logging operation, and just a little bit transport operation, and it's about 6 to 8 weeks, this break of operation, and all restarts at the mid-June, but not at the same scale as in winter. It's now when the woodyard subject comes in to better use the transport fleet. It's the case of the terminals, transshipment yards, satellite yards, and to efficient handling and storing wood at the mill sites. So if we speak about talk about woodyard, the most important thing is their design. So I present some design decision based on mill yard, but it can be applicable for other types of wood yards. We can start with general theory of inventory management, because a wood yard is a specific case of a warehouse implemented in forestry sector. So the design of a warehouse involves 5 decisions at strategic level. So the first one is general structure. determination. So overall structure defines the flows, wood flows within the warehouse, within the woodyard, and specification of functional departments. Then sizing and dimensioning is to determine the capacity of the woodyard in terms of space, as well as allocation of space between departments. Layout determination, so how to locate different functional departments, as well as infrastructure, roads, entrances, and product allocation in storage zones. Equipment selection starts with selection of automation level, then handling system selection. It can be mobile, fixed, or combined. And finally, a type and number of particular machines. And the selection of operation strategy. The main operation of a warehouse are reception, storing, order picking, and shipping. And those operations require a good allocation of resources, for example, space, equipment, and good coordination of those operations in order to be efficient. Those decisions are interrelated, and we cannot consider them separately. So let's start with layout, woodyard layout. So we have to decide how to locate different departments with required infrastructure. So what do we need in the woodyard as infrastructure? First of all, we need a wide scale for the trucks, because in Quebec we still use mass volume measurement. It means that each truck has to be weighted at the reception and just before leaving to establish the wood load. And with that, we can apply some conversion factors to have the volume. So scale, measurement zone, because to calculate this conversion factor, we have to measure some wood sample from the harvesting sectors. Truck cleaning area, unloading and storage zones, one or several storage zones, mill deck and short-term storage, all the buildings, so all processing buildings, staff buildings, garage, parking, entrances, and in Quebec, the place for storing the snow as well. So we have to select our department to calculate the necessary capacity in terms of space. Then we should to place them on the plan, considering the site constraints, such as, in this case, for example, the public road, the slopes, electrifiers, and so on. So if there's so many constraints, we can divide our storage capacity into several zones. At the same time, we should to plan the roads to ensure equipment, mobile equipment. And at the end, we should to plan inside of storage zones, for example, to assign the space for particular assortments. Then equipment selection. So after we choose the handling system, in this case is mobile, you should to focus on the particular type of machines. So it should be based on several criteria. I put some of them on the slide. So if our machine will perform only one task, such as unloading, one main task, or it should perform also additional tasks, such as yard maintenance or snow removal. If our woodyard is large and there's a lot of distances, the best choice would be a lock loader with the trailer. If not, if the woodyard is small, the front end loader will be more performant. But if our log yard is small and we have a lot of stocks, so we cannot use the front end loader because it can reach only up to 4 meters. Of course, the important thing also to look at is the investment level. So how much we can spend on a machine. For sure, the front end loader would be less expensive, but maybe the not most performant for all the operation. If you ask a woodyard manager in Quebec, what is the most important characteristics of efficient woodyard, they'll immediately answer you to have enough space. Even if log yards, woodyards in Quebec are actually large, but how many hectares is to have enough space? So There is no common method for estimating the required space. The wood yard managers calculate them mostly based on a maximum volume with a safety factor. And for sure, in Quebec, we have to provide some space for the snow. It should be pointed out that the sizing decision is closely related to other decisions and significantly influence them. For example, if we have a lot of stocks, high volume, so we have two choices. So the first one is to have the high wood piles. In Quebec, it's up to 12 meters. I saw many times 9 meters. But for this solution, we have to use the equipment allowing safe operation at 9 meters. So the first choice is. The second one is to have narrow corridors, but we have to use small equipment. In both cases, the wood inventory and control is more difficult. We cannot apply the freshness rule. And unloading the truck at this 9 meters takes more time, but we use less space. So we spend less money on the yard maintenance, and as well our mobile equipment drive less kilometers. So based on all of this, if you take all of this together, how can evaluate if our wood yard is efficient? In fact, it's a complex task because of many factors influencing wood yard design and operation. To mention only a few, the first one is the seasonality of wood supply, imposing the wood yard operating with different volume levels during the year. So it impacts the operation as well intensity of operation. So different operation can be performed during the year. Then location and neighborhood, imposing environmental limits and noise limits and available to extension area. So all these factors influence the operation, determine the operation, influence design, and the operational performance is closely related to the design, and we should question our design based on the symptoms, operational symptoms, such as space or the long distances to transport the wood from the storage area to the mill deck. So what if we should reconsider our design based on those symptoms? How it should be done? So that's what was the question I decided to address, in fact, in my PhD project, divided into 3 steps, as you can see on the slide. So the first step was to document the current practices in wood yard design, operation and management through the research paper as well as practical cases. And these practical cases, we use survey and on-site visits to document the practices. So we collected such interesting data. Then we did some analysis with statistics, and this data was used to the performance assessment. So we built a benchmarking tool, overall performance efficiency, a benchmarking tool to assess the efficiency level, as well to find the practices influencing the most the performance of wood yards. And those 2 steps were used in the final step to develop a wood yard design method, considering the conditions of wood supply, mostly seasonality. So we did collect some KPIs by our survey, but we couldn't use them in our benchmarking tool because of excessive variation in those KPIs. The sample wasn't really large. It was 38 wood yards. So we decided to give some structure to our benchmarking method and decided to use data development analysis as a tool. It's a method measuring the technical efficiency, so the transformation of input into outputs. So the method identifies the most efficient unit They form the efficiency frontier, and the other ones are enveloped by this frontier. For inefficient unit, the method provides information about the level of inefficiency as well as the source of inefficiency. And the level of inefficiency could be measured by the distance between the unit and the efficiency frontier. We started with the basic DIA model. Then, because this method requires that all the assessed units work with similar operation condition, it's not the case for our wood yards. So we had to incorporate the complexity index, so the operational difficulty factor, and those two measures were used to establish the common points of the best and worst performers. In our model, we used 3 inputs compared to 1 output to assess the performance level, technical efficiency of 38 decision-making units, wood yards. So the inputs were area, replacement cost of handling equipment based on the type and the size of machines, and the number of employees hours for 24-hour period. So those inputs were compared to annual volume and annually in the yard. We oriented our model towards the inputs to assess how much of our inputs we can reduce to be efficient while still maintaining the same level of output. In this exercise, so performance assessment exercise, we noticed that one of the important factors influencing woodyard performance is the shape of a woodyard. In fact, just a few woodyards in Quebec have a shape minimizing the distance between the storage area and the mill deck. The first picture represents the best shape of woodyards in Quebec. So woodyards take the shape, rectangular shapes with several storage spots along the road with different several storage zones, close or far away from the mill deck. Here, the distance between the storage zone and the mill deck, which is here, somewhere here, was 2 kilometers. So that's a lot. But the most important factor influencing their performance is the seasonality of food supply. So on the figure, you can see the inventory level during 1 year of operation from surveyed yards in Quebec. As you can see, the maximum is reached in March, while the minimum is stored in June, which is consistent with seasonality of food supply in the 2 period. But the seasonality of food supply doesn't affect all woodyards in the same way. Here we have 2 level stocks, 2 woodyards. So one with quite stable stock levels and one with a lot of variation, a lot of fluctuation. So in here, the difference between minimum and maximum stored in the year, it was 90,000 cubic meters. That's a lot. That will influence our decision. So how I can establish the capacity of equipment for my woodyard based on which period, and how I manage the insufficient of over capacity during the year. As I mentioned, the DIA method requires that all the units work in similar condition. If not, we have to incorporate the external factor and operational difficulty in our performance assessment. So we consider for it 3 factors. So the seasonality, number of assortment having an impact of space utilization, and the shape index. So we incorporated the measure of complexity of operation as the combined impact of those 3 factors, assuming that the woodyard with more seasonality, more assortment, and with a dispersed wood shape will work under difficult conditions. So in DIA method, we can use at least 2 models to assess the technical efficiency. So the first one is CCR, assuming the constant return to scale. So it assumes that all the units work at the optimal scale, so the scale maximizing the returns. And the second one, measuring the so-called pure technical efficiency, deals with variable return to scale. So the transformation of input into outputs under size constraint. Therefore, this method can also provide the information if our wood yards work at optimal scale. The scores for technical efficiency take the value from 0 to 1. 1 is efficient unit. So on the first figure, we can see the results of our wood yards in these 2 models. So on average, the technical efficiency in constant return to scale was 61%. And the pure technical efficiency was 81%. So 19% of inefficiency indicate the need for improvement in input consumption, so our resources consumption. And there's lots room for improvement also at the scale level, because 23% of inefficiencies is due to the fact that the wood yards work at less than the optimal scale. One of objectives for performing the relative efficiency assessment is to find the opportunities for improvement. On the figure, we can see the input reduction target based on available resources in order to be efficient for a wood yard. So as you can see, on average, we can reduce our area by 5 hectares, reduce our equipment investment by $450,000. At the time I performed this analysis, it was the price for small and front-end loader, and to eliminate 1 shift of work. But as our wood yards work under different conditions, we should take it into account in the input reduction. So our measures of complexity index and technical efficiency were used to find the common point of the best and worst wood yards. So the median values of those measures divided our sample into 4 groups. So the median of technical efficiency divided our group into more efficient and less efficient, and a complexity index median divided our sample into good and difficult operation conditions. And we focus on 2 groups. So the green one, the best log yards, wood yards, with difficult condition, and the worst one, even with good working condition. And we compared several practices in these 2 groups in order to find the common point of the into these groups. And based on available data, which was the most limiting factor, we find out that the worst performers use an old equipment on the unpaved roads. Unpaved roads, unpaved coating is not only efficiency problem, it's also an environmental problem because of residue management. As you can see on the picture, there's a lot to do in this area, and is the reality of many wood yards in Quebec. So now, after benchmarking, I will talk how to proceed to design efficient wood yard. So from the previous 2 parts, we knew that we need a method, structure method, because of 1/3 of wood yard managers finding their wood inefficient. And we needed also flexible design method, because our design adapt to seasonal variation. So we looked at available methods in the literature, in the wood yard area, but also in inventory management discipline. So about warehouses, there is a lot of research paper dealing with by optimization of several sub-problems or sequential approach to organize the complexity of decision. In contrast, for the woodyard, there's only a few papers, mostly dealing with inventory management or operational performance, but we found two design methods published in early 80s. Hampton from United States and Sinclair and Wellborn from British Columbia. But we couldn't use these methods in our case as personality of food supply. Then there was also a gap in the step of performance evaluation because it was presented too general and needed clarification. So we identify a gap to create a method considering the supply variation. So we decided to complete the Hampton method because in our opinion it was more structured than the other one. And what was the Hampton's method? It was a sequential approach starting with data collection of data of supply, lease demand, yard location to establish design constraint, then the flow analysis of wood within the wood yard to establish the proximity links between operation and prioritize the most important operations. Then determination of capacity in terms of area and equipment, and then to locate the functional department on the plan and evaluate the performance of those design. So that is Hampton methods, and we decided to complete this method within two aspects. The first one was adaptation of the design to seasonal variation by determining the seasons. We consider 3 seasons: rundown and equilibrium season, to determine the triggers to change the season and alternative design for each season. So our year of operation will be divided in the period seasons, defining by the number of weeks, with the same operation distribution within the season, and our design will consist of a series of design appropriate for each season. And for the performance evaluation step, we decided to use descriptive in simulation because this tool is efficient for evaluating the dynamic elements such as supply. As Hampton considers only fixed decision at strategic level, we incorporated flexible decision in the design process. An example of such decision is seasonal sharing of space between functional areas. So as you can see on the picture, for a given season, several sets of fixed decision can be developed, to which several steps of flexible decision can be associated. So we can have several solutions, and then we can simulate with descriptive simulation the solution for each season, then collect some performance criteria to facilitate the decision making. So the method can be applicable to entire mill site, storage department, or other specific functional department as revision of existing design, or to build a new facility. The entire method is based on the flow analysis. So the first thing to do is determine the sequence of operation, then the percentage of wood flows in terms of volume will serve to find the proximity level within the operation, between the operation, and to prioritize the most important operation in order to determine the best design to evaluate after. In In the case we have the data for 2 parts of mill site, we can also proceed to analysis of both of log yards and lumber yards. Any benefit to different allocation of space in the season, in different season. If the flow are different regarding the season, we should to perform this for each season. So based on flow analysis, we developed 9 scenarios. So 3 design configuration for 3 seasons, and we needed a simulation model to evaluate the performance. So I will build one in Simio software. Simio software is a good one because it's really easy to learn how to model in this software, but also it's really easy to validate the operation with yard manager, because it's really we have a good vision of operation, can follow the operation. The main groups of modeled activities were track arrivals and their sequences, modeled differently for any wood origin because of different track arrivals frequencies, and mobile equipment activities reproducing the behavior of those machines. So the priority of them was to ensure that the mill deck doesn't run out of logs, then unload the tracks, and then if the mill deck is full and there is no track to be unloaded, so the machine proceed to transport the wood from the storage area to the mill deck based on freshness rule. We did 50 repetition for each scenario, and then we collected 3 KPI. We choose track cycle time, distance traveled, and equipment utilization rate, because those indicators represent internal performance of woodyard, and they can easily be transferred to financial measure at operational level. So based on results, which is the average value of indicators during 1 year of operation, we can easily eliminate the design which doesn't work. It's, for example, the third design for the first season because equipment utilization rate exceeding 100%. For the rest, we should consider the enterprise strategy, because a sawmill with high level of stocks will prioritize the distance. The other one who owns the fleet, transportation fleet, will prioritize track cycle time. So for the final decision, we should speak to woodyard manager. There's also some factors to be considered as well. So financial and technical feasibility, potential for expansion, ability to adapt to changes, traffic safety, and other possible factors to be considered. So that's all. Thank you very much for your attention.
Thank you, Marta, for your insight from Canadian Forest. For our attendees, on the top part of the screen, you have the Q&A button where you can ask questions. And while you'll be doing that, I have 2 questions to ask Marta. And first will be probably easy, because you mentioned that every woodyard has some kind of guarantee. Can you describe again how it is being calculated? Do they have to send their preferred capacity that they are able to use every year, or what? Is there any calculation? Because I can imagine that the market for wood is similar here, meaning that there's not enough wood for everybody. So it has to be some kind of competition between the woodyards for the wood.
So to answer that, I don't know the exact mechanism of calculating this volume, but it's based on historical data, mostly, then calculated, corrected by available volume, and for a 5-year period. But now with the United States taxes on wood, there's more and more sawmills that finish to they are closing now. So there's less and less competitive in the
So
woods.
you mean they are closing because there's no wood coming from the US?
No, there's the taxes on the products of sawmills.
Okay, so they cannot export.
Yeah.
Okay, I get it. Okay, and during your presentation, you've been showing us some statistics about the when you were calculating the efficiency. You showed us, for example, that the biggest woodyard that you had in your data was 58 hectares, and that the biggest one also processed almost 1 million cubic meter per year. Have you visited bigger ones? I mean, maybe you didn't include them in your analysis, but are there bigger in Canada? I'm just thinking about the size. I'm not an expert here, but from what I saw in Poland, they are not that big, or not the ones that I saw. So how would you compare the woodyards here in Poland to Canada?
So I didn't visit a log yard with this area of 58 hectares because it's really in the north side. But in Quebec, the wood yards have a lot of problems of space utilization. So there's a lot of space, so we can store the wood anywhere we want. So there's no consideration of that. A little bit, yes. In fact, it depends on the wood yard, but so that's the problem. Then in Poland, I visited some wood yards in Slovakia with less space, with less capacity of space. Proceeding the largest one, it was the paper mill, proceeding 3 millions of cubic meters annually. But the sites are large as well, not 58, but more than 20, 30 hectares.
So from what you're saying, would it mean that these that are here are a little bit more efficient? Would you dare to say so?
It's different. It's different because here there's no seasonality.
Oh, if I look out of the window, I can for sure say that. Okay, any questions from the audience? I don't see any questions in the QA. I don't see any raised hands. Okay, I think that you have said all from the topic that no questions are being asked. Okay, thank you for this. Thank you for your presentation and sharing your time with us. It was a pleasure. I hope that your research will be developing in this area as well. And for our audience, I have a short communication. I have just one slide to show you. I hope it will be loaded properly. This was today's presentation, and we just saw a presentation about a woodyard performance design and run by Marta Trzcianowska from Warsaw University of Life Sciences. But I already know the name of the new presenter of the upcoming 4th seminar of JRC4, which will be run by Joaquim Sande Silva from Polytechnic University of Coimbra in Portugal. Joaquim will be talking about aliens and flames, but aliens meaning alien species in forest. From what I know, he will focus his research mostly on eucalyptus and acacia. But let's see what will happen on the presentation on the 24th of February this year, also on 2 p.m. Central European time. So the link will be provided through your UNIgreen coordinators. I hope I can do this that week. And thank you, Marta, again. It was a pleasure to see all the attendees with us today. Thank you for being with us. Have a good day. Bye-bye.
Thank you.